So today let's go through, I call it practice B, but it's the fall 2013 final. See how, see if I can get all these right. Right, number one, using complex numbers, find all of the solutions. This one's actually pretty easy. X plus 3 squared equals -4. How do I know that those are going to be imaginary? We have an x squared equals a negative number, so I square root, and I get x plus 3 equals plus or minus 2i. Subtract 3, -3 plus or minus 2i. All right. Number 2, x squared plus 100 over x squared minus 2 is less than or equal to 0. And the question says, which interval represents the solution of the rational inequality? So we got a couple problems here. Does this not have answers? Uh-oh, maybe the... Okay, so for this one, we have a couple problems. First off, we have a function in the denominator. So x squared minus 2 is not allowed to be 0. So if we add 2, we get x squared equals 2. Square root x is not allowed to be plus or minus the square root of 2. Okay. And the other domain problem we would have is if there was a square root. We don't have any square roots. So we just, the bottom is not allowed to be 0, and there are no square roots to worry about. So we have 3 intervals. So if here's 0, we have the interval from -√2 and √2. So this one, and this one. And we want to know what intervals create a true inequality. So we just plug them in. So -√2 is -1.4. So let's try -2. If I plug in -2, I get a positive number. If I plug in -2 divided by a positive, so positive over positive is positive. Is that less than 0? So this is false. If I plug in 0, is 100 over -2 less than 0? Yes, so that would be true. And the one on the right, we plug in 2, which is going to give us the exact same answer as -2. We get a positive divided by a positive, which is positive. So this would be false. So my interval has got to be B. Oh, pay attention to the inequality sign. Glad they put that there. Number 3, using interval notation, specify the domain. So there are 2 problems with the domain on number 3. What are the problems? X cannot be 0 because that would create infinity, or negative infinity, depending on how you looked at it. And x minus 10 has to be greater than, equal to? Is 10 okay? So I get, add 10. So I get x is greater than or equal to 10. So my domain would be 10 to infinity. What about that x cannot be 0? So if we look at the number line, it can't be that, but it has to be everything from here over, including 10. So that x cannot equal 0 didn't even matter because it gets swallowed up in that other part. So the answer has to be B. You'd have to change your window. The trouble with graphing it is, you can't see equal to's, and if the graph gets really steep, so let's say that the actual graph was here at 8, it gets really steep, your calculator might only graph this much of it, so you might think it, anyway, because our calculators are so pixelated, it can be a little bit difficult. You could use the table. The table would help. All right. Number 4. Starting with the function square root of x, you want to transform the graph by first reflecting the graph across the y-axis and then shifting vertically down 3 units. Which of the functions would be appropriate for the resulting graph? How do you do a y-axis reflection? Negative where? So if we reflect across the y-axis, did we change the x-coordinates or the y-coordinates? The x-coordinate switch, so it's got to be negative x. And then we do the square root. And then we want to go down 3. So we would subtract 3. So that would be... No, if it's inside the square root, that would be a horizontal shift. Right? So the function is square root. So that is the x portion. Anything that happens inside affects the x values. And then that is the function, so anything that happens outside the square root affects the y values, because the function is the square root of x. So anything under the square root changes the horizontal. Anything outside the square root changes the vertical. Number 5. A. So the function square root of x minus 2 plus 4 is 1-to-1. What does 1-to-1 mean? It's a function and there's 1x for every y, which means it's invertible. So a function means every y or every x only goes to one y, but the y, there can be multiple y's, but 1-to-1 means every x has one y and every y has one x. Essentially, a function passes the vertical line test, and a 1-to-1 function also passes the horizontal line test, which means it's invertible. So using interval notation, the range of f inverse is given by, well, the range of f inverse is going to be equal to the domain of f. So the domain of f, what numbers can you not plug in? Anything less than 2. So the domain of f is from 2 to infinity with a bracket, which is equal to the range of f inverse. And you could graph that if you wanted to. How do you invert? You would set it up as x equals the square root of y minus 2 plus 4. And then x plus 4, then we would square it, plus 2. But it's not that entire graph. It's only half of the parabola. So the original graph looks something like this. And then if that reflects across that, it's only the right side of that parabola. Okay, number 6. Given f and g, determine the domain of f of g. Do f and g have any domain restrictions? F is greater than or equal to 1. Okay, so when I compose them, so f of g means we plug g into f. So I'm going to take x squared and stick it inside the square root of x minus 1. So my domain is going to be kind of tricky, huh? So f is the square root of x minus 1, and x has to be greater than or equal to 1. Does g have any domain restrictions? No. So g is x squared. That has no domain restrictions. Does this have any domain restrictions? So it has all of the originals, and did it create any new problems? Well, in this one, x has to be between 1 and -1. Right? 0 would be a problem, but 0 is already a problem up here. Or sorry, these are not equal to's. So x cannot be between 1 or -1. -5 is okay, but -5 is not part of the original domain of f, so the original domain of f becomes the new domain of f composed with g. Okay? So there are a couple things you need to look at. You need to look at the domain of f, the domain of g, and the domain of f composed with g, and you take the smallest set. So you look at all of those domains, and the resulting domain is the smallest group of those three. If f had a domain restriction, that is preserved. If g has a domain restriction, that is preserved. If f composed with g creates a new domain restriction, that is also preserved. So the answer is A, right? Right. So A. Well, the composition was everything not in between 1 and -1. But F had a restriction that was narrower than that, so we just go with F. Which of the following statements is true? So 300x over 2x squared plus 8. Does that have any domain restrictions? Does the denominator ever equal 0? Now I pull out a 2 and I get x squared plus 4, which has irrational roots. So the bottom never equals 0, which means there are no vertical asymptotes or holes. Okay. So the graph of the function has only one vertical asymptote. True or false? False, it has none. The graph of the function has a horizontal asymptote at y equals 150. So the degree of the top is smaller than the degree of the bottom, so the horizontal asymptote would be 0. Whenever the bottom is bigger than the top, the horizontal is 0. What if this was x squared on top? Then the horizontal would be 300x squared divided by 2x squared, which is 150. But in this case, it's not. What if this is x to the third? Then it would have a slant, and you'd need to use long division to figure out what that slant asymptote is. But it would have a slope of 150. Okay. Letter C, the domain of the function is negative infinity to -2 union with -2 to infinity. No, we decided it has no domain restrictions. We don't have to worry about square roots, and the bottom is never 0. As x approaches infinity, f of x approaches 0. So if we look on the far right side of the graph is approaching 0. True or false? True, because, which means it has a horizontal asymptote at 0. So the bottom is a larger degree than the top, so the horizontal asymptote is 0, which means as we go to the right or the left, we're going to approach 0 in both directions. Right? And you look confused. Did you parenthesize the bottom? That would be why. Okay, E, the graph of the function has a slant. No. Slants only occur when the degree of the top is 1 larger than the degree of the bottom. All right, number 8. A manufacturer of cleaning solvents has determined that they can model their daily profit using the following function, which is a quadratic. for any x greater than 0, where x represents the number of liters of solvent ordered by distributors for a particular day. According to this model, what is the maximum daily profit? So what do we do? Graph it. Maybe. When you guys get to calculus, maximizing is a lot easier than this. The trouble with maximizing right now is we have no way to figure, at least not a good way, to figure out where the maximum occurs. So the only way to do this by hand is find the roots. I take the average of the two roots and then take that answer and plug it into the function. But in calculus, there's a really easy way to find where the maximum is, and then you just plug that number in to find what the maximum is. So we need to go to our window, 0 to, I don't know, we're going to guess. So the answers are in the 0 to 200 range. So I don't know how many liters that is. And then you want to do zoom fit. And I was way too big. You could use your table, but it might not be perfect. If it ends up being a nasty number, then the table, oops. So zoom 0. There we go. So, oops. Calc. We want the maximum. That number. Of course, I guess if you find one of those nice numbers on your table, then you know that that's right. Okay. So 18 liters gives 202.5. Is that always going to be the case? Didn't we do a problem yesterday where that constant was the maximum? I wonder if that's always true. So if we had negative a times x minus h squared plus k, is that always going to be the maximum? Because that was the same thing that happened yesterday. I don't know. Somebody figure that out. Let me know. As of now, I wouldn't trust that. I would work it out. Number 9. Given that x equals 2 is a 0 of the polynomial, which of the following is a factor? So if x equals 2, then x minus 2 is a factor. I recommend synthetic division. Are we missing any terms? So no, 1, negative 14, and 24. And I know that my remainder is going to be 0. If it's not 0, you mess something up. So drop the first one. Multiply, we get 2. Subtract, we get 1. Multiply, we get 2. Subtract, we get 12. Negative 24. Okay, well, I knew that was going to happen, so what was the point? So now I have x squared plus x minus 12, which is x plus 4 and x minus 3. So my other two roots are 3 and negative 4. Oh, wait, it wants the factors. So D. I think this is more representative of the current curriculum. They must have changed the curriculum between 2010 and 2013. This is more along the lines of what we studied, right? Okay, x equals 1 is a 0 with multiplicity 2. Using complex numbers, which of the following statements is true of this function? So x equals 1 is a 0 of multiplicity 2. So we probably want, we could do synthetic division twice, or we could do long division using x squared plus 2x, no, 4x plus 4. But the synthetic division twice probably makes more sense. So 1, -2, 5, -8, and 4. And once again, I'm going to have a remainder of 0. So 1, 1, -1, -1, 4, 4, -4, -4, 0. And I do it again. And I should get another remainder of 0. So drop the 1, times by 1, 0. 4, or sorry, that's 0. So this is 4, and 4, and 0. So I end up with x squared plus 4. So letter A, the equation has only one real solution. Oh, what do they mean by, anyway, that's a tricky question, right? Do they mean one with a multiplicity, or there's only one? Anyway, let's go through the others. B, the function has no imaginary solutions. That's false. It has 2, plus or minus 2i. X plus 2i is a linear factor of f of x. Yes, the other complex linear factor would be x minus 2i, so that's true. The graph of f of x has 2 x-intercepts. That's false. It only has 1. So my guess is A would be true. No, it can't be. Oh, only real solution. Okay, never mind. A's false. I totally read that wrong. So C, it's got to be C. Hey, is somebody writing? Somebody keep track of all these letters, because I'm going to put them on the website. All right. 11. Using complex numbers, which of the following statements is true concerning the polynomial function x to the 4th plus 4,000x squared? (400x squared). What are the roots of this? 0, 0, and plus or minus 20i. If we pull out an x squared, we get x squared plus 400. So 0 has a multiplicity of 2, and then x squared plus 400 turns into plus or minus 20i. So A, the graph of the function touches the x-axis only once. But it only has one actual x-intercept, so that's true. B, the function has no real zeros. False. 0 is a real number, so that one does exist. The graph of the function has no x-intercepts. That's the same as B, so it's false. This function cannot be written as a product of linear factors. Well, the linear factors would be x, x, x plus 20i, and x minus 20i. So that actually can happen. So A is the only correct answer. All right. The function e to the x minus 40 minus 47.2 has an x-intercept given by which of the following? So we want to know, where does e to the x minus 40 minus 47.2 equal 0? So e to the x minus 40 equals 47.2, ln both sides, drop the x minus 40, and the ln of e cancels. So x minus 40 equals the ln of 47.2, and then I add 40 to that. So the answer is C. All right, 13. Solve the equation. Log of x plus log of x plus 3 equals 1. Can I drop logs in this case? You can only drop logs when you have logarithm equals logarithm. And this is a logarithm problem. So when we get our answers, we need to plug them back in and make sure we don't take the log of a negative number. I can use the product rule to combine those. So log of x times x plus 3. And there's no base on this, so it's 10 equals 1. So 10 to the first equals x squared plus 3x. So I subtract the 10. Are there factors of negative 10 that add to be 3? So x plus 5 and x minus 2. So I get x equals negative 5 and 2. Are either of those a problem? Negative 5 is a problem in both logarithms, and the 2 is not a problem in either one, so it's just 2. All right, number 14. Log base 3 of 9 over x to the third. That can be expanded. So we're going to use the quotient rule. The quotient rule is going to create a positive logarithm there and a negative logarithm here. So log base 3 of 9 minus log base 3 of x to the third. Is there anything else I can do? Well, this doesn't have any x's in it, so it's just a number. 3 to what power is 9? 2. So that's just the number 2 minus, can I alter the next one? I can use the power rule, which allows me to drop the exponent out front. So 3 log base 3 of x. Do these cancel in any way? No, they don't. So that answer would be B. Okay, 15. Using partial fractions. The rational expression can be written in an equivalent form as the sum of two rational expressions. Determine the value of the numerator for the x minus 2 term. So 2x over x minus 2 squared. How many unique linear factors do I have? Unique linear factors. 1, are any of those factors duplicated? Yes. So because I only have linear factors, I'll only have a's, b's, and c's. I won't have any ax's plus bx's because I don't have any quadratic factors. So I'm going to have a over x minus 2. But x minus 2 actually occurs as a duplicate, as a multiplicity. So we're going to add b over x minus 2 squared. Now, we need all of the denominators to be the same. Are any of the denominators missing a portion of the common denominator? Just the a term. This needs an extra x minus 2 in order to match the other two. So that gets an x minus 2. This already has the common denominator, so I don't need to mess with it. Now that all the denominators are the same, I can cross them off. And I get ax minus 2a plus b is equal to 2x plus 0. So I group my x's. A equals 2. And I group my constants. Negative 2a plus b equals 0. Do I even want to bother with the matrix here? No. A is 2. Oh, we're done, right? It wanted my x minus 2 term, which is 2. If it wanted the other one, I would just plug 2 in there. Negative 4 plus b equals 0, so b would be 4. But it wanted the numerator of that term, which is 2. You guys feel more confident about this test, right? Given the following system of equations, determine the value of y in that solution. Well, this is easy. Go into matrix. Go over to edit. This is a 3 by 4. And 1, negative 1, 1, 8, negative 6, 6, negative 6, 12, and negative 4, 1, negative 1, and negative 4. So then we exit out and go back in. We want to do the RREF. Out of matrix A. So the y value, did I mess something up? Oh, what's the problem with this? Two of them are, yeah, the first and second equation are the same, but they have different answers. So if you look at the bottom row, 0, 0, 0, 1. When does 0 plus 0 plus 0 equal 1? Never, so this is no solution, which the fancy algebra term for that is inconsistent, as opposed to consistent. But the reason I don't like that term is infinite solutions is consistent. One solution is also consistent. There is an answer. But then you get into dependent and independent, and anyway. So the answer is D. 17. Consider the following nonlinear system. The solution is, what are you going to do? Well, squaring the top's a problem because you actually do x minus y times x minus y, which is x squared minus 2xy minus y squared. That'll work, but you don't want to do it that way. I would use substitution. So x is equal to y plus 2, and I'm going to stick that, put that in here. So I get y plus 2 squared plus y squared equals 2. So y squared plus 4y plus 4 plus y squared minus 2 equals 0. So I distributed out that original and then subtracted the 2 to the other side. So that's 2y squared plus 4y plus 2. Cut that in half. Y squared plus 2y plus 1. Does that factor? So y plus 1 equals 0. And it's actually squared. It has a multiplicity of 2, but that doesn't really matter to us. So y equals negative 1. And there's the answer. The other way to do this would be solve for y in both cases and graph, which is kind of a mess, because you have to graph. So that bottom one is a circle. So you'd subtract the x squared over, you get 2 minus x squared, and then you square root it, and you have to graph the positive square root and the negative square root. So this ended up being easier. 18. For all real numbers x, ln of x squared equals 2 times the ln of x. Is that true or is that false? What question is that? So ln of x squared is equal to 2 times the ln of x. That's the power rule, right? Is that true for every possible number? Good. So what about any negative number? Let's say negative 2. Does negative 2 work there? Yes. But does negative 2 work there? No. So false. All right, so the USU pattern for the final is they will give you 5 questions on the free response. You pick any 4 of them. And then it says cross out completely the problem that is not to be graded. So it doesn't mean you do them all and then we drop your lowest score. It means you pick 4 that you want graded and 1 you want ignored. So you have to make that decision. I'm not allowed to make that decision. Okay? Now if you leave one blank, yeah, that's the one I'm not going to grade. But you might want to solve them all and then just cross one of them out. All right. Concentration milligrams per liter. We did one of these yesterday. So that formula looks really fancy. We're going to turn it into y equals 200 e to the negative RT. So K is the decay constant, T is hours, and C is the ending concentration after T hours. So at T equals 4 hours, the nurse determines that the concentration of the drug is 50 milligrams per liter. That is, C of 4 is 50. How much did the concentration start at T equals 0? 200. This is the initial amount. So if we plug 4 in for T, we can plug 50 in here. So 50 equals 200 e to the negative R times 5. 4. What's my first step? I need to divide by 200, which is 1/4. So 0.25 equals e to the negative 4r. ln both sides. Drop this. ln of e cancels. So the ln of 0.25 equals negative 4r. So I'll just take the ln of 0.25 and divide that by negative 4. So the answer is, what does that mean? What's the decay rate? Which is a percentage, right? So it's about 35%. We're going down about 35%. Well, this is kind of a gray area. The equation is PE to the RT, where if R is positive, then it's growth, and if R is negative, then it's shrinking. So the only difference is, if I don't put the negative in there, then I don't divide by negative 4, and I get negative 0.34. So it doesn't really matter if you use it, as long as you understand what the negative means. So we're dropping by 34%. The confusion, you can't say, oh, 0.35 means we're going down 65%. Right? If we keep 35, do you remember that? So that's not what's happening. In the PERT equation, the number you get is the actual rate. You don't have to adapt it as a difference of 1. Okay. Number B, another drug is given to the patient to prevent blood clots. New equation. So that one's dropping by 40%. The nurse would like the amount of this drug in the bloodstream at time t equals 4 to equal 80 milligrams. What is the initial amount? So this one we're going to solve for a sub 0. So we want to end with 80, and I'm just going to use p. E to the negative 0.4 times 4 hours. So what's holding the p? to everything else, multiplication. So I'm just going to divide by e to the negative 0.4 times 4. So 80 divided by, and make sure you use parentheses here. I don't need to because I have the newer software. So we have to start with 396 milligrams. Okay, number 2. A doctor noticed a circular mole on the skin of a patient that has been determined to be cancerous. She has initiated chemotherapy, treatment, and conditions to monitor the size of the mole. She determines that the radius of the mole is changing over time t, measured in days. The relationship between r, which is the radius, and t, which is the time, can be described by the function the square root of 100 over t plus 1. The area A of the mole is a function of the radius and is given by A equals pi r squared. Using the concept of composition of functions, determine the area of the mole as a function of time. So right now we have two functions. We have radius given time. That's the first equation. And the other one is area given radius. And what we want is a function that will give me area given time. How are we going to accomplish that? Well, we're going to compose, so we're going to plug one into the other. Do we want to plug the area formula into the radius formula, or do we want to plug the radius formula into the area formula? We want to plug area, or the radius, into the area, so we want area composed with the radius formula. So I'm going to plug this in here. So the radius formula is the square root of 100 over t plus 1, and the area is pi r squared. So that equals r. I'm going to stick this in here. So pi times the square root of 100 over t plus 1 squared, which those just cancel, and I get 100 pi over t plus 1. Hi. Who's your teacher? Take it to him. So this formula will give you the area of the mole when you plug in the time. And we don't need, so 100 pi over t plus 1. Letter B, when the mole reaches an area of 50 square millimeters, the doctor will terminate the chemotherapy treatment. So when is that going to equal 50? That's easy. Just cross multiply. So 100 pi equals 50 t plus 50. So it's 100 pi minus 50 over 50, which is just 2 pi minus 1. And I want you to plug that in. So 6.28 minus 1 is 5.28. And these are in days. Well, that would be nice if chemotherapy only lasted 5 days. Not sure they would do chemotherapy for a mole, but whatever. 50 square millimeters, that's pretty big, right? Number 3, due to a decrease in demand, this small production facility that bottles pure mountain water is cutting back on the number N of gallons of water being shipped each day. After X days, the number of gallons being shipped is given by the model 1,000 over X plus 500. Determine the inverse. That's easy. X equals 1,000 over Y plus 500. So the inverse is going to be X minus 500 equals 1,000 over Y. We could multiply by Y and then divide by X minus 50, or if you remember back from your trig days, we can just switch these. Y equals 1,000 over X minus 500. Okay, using the result from part A, determine how many days it will take for the number of gallons being shipped is equal to 515. So we just set this equal to 515. Cross multiply. 1,000 equals 515 times X minus 500. So I'm going to divide by 515 and then add 500. Where did my calculator go? I don't have a calculator anymore. Somebody want to calculate that? I must have closed it. So 1.94 plus 500, so 501.94. Oh wait, we're subtracting. No, we're adding. Did I lose you? Where did I lose you? Oh no, we can. I'm trying to get this in before the bell rings. All right. Number 4, a large company frequently hires new welders. The percent P of defective welds made by a new welder tends to decrease over time. The company uses the following model to predict the percentage of defective welds made by a new welder, where T is the time in months that the welder has been employed at the company. So we have the function y equals 5t plus 15 over 4t plus 1. What happens as we go to the edges of these graphs? Where is the horizontal asymptote? So the degree of the bottom and the degree of the top are the same, so the horizontal asymptote is going to be the ratio of the first two terms. So 5t over 4t is 5 fourths, 1.25. So apparently, even the best welders make 1.25 welding mistakes in a month. So this graph is going to have limits on either side at 1.25. And the number of welds decreases, the number of mistakes decreases. So it's probably going to look something like this. Okay? According to this function, what percentage of defective welds will an employee be producing at T equals 1 month? That's easy, just plug in 1. So 5 plus 15 is 20. 4 plus 1 is 5. 20 over 5 is 4 mistaken welds a month. So 1 month, the answer up here is 4. According to this function, how many months will a newly hired welder be making 2% of their welds as defective? Oh, that's a percentage, so it's a 1.25%. Okay, so we want to set this equal to 2. We cross multiply. 5t plus 15 equals 8t plus 2. So that's 3 equals, did I do that right? 3 equals 3t. Oh, there we go. That makes more sense. 5t plus 15, so 13 equals 3t, so 13 thirds, which is 4.33 months before they get it down to 2%. Now the best they can do is 1.25%. In the long run, what value of the percentage of defective welds made by a new welder approach? So we know that the horizontal asymptote is 1.25, so as we go out to infinity, we approach 1.25. All right, I think we're going to make it. Number 5. The profit that a company makes from the monthly production and sale of X tons of lawn fertilizer is given by the quadratic negative 0.4x squared plus 240x minus 11,000, where x is between 0 and 600. What is the maximum profit? Piece of cake. Graph it. And I already know my x values, except I don't have a calculator anymore. Why would I turn that off? So you'll graph that function. You'll set your window from 0 to 6,000, 600, and then do zoom fit, and it will pick the y values for you. Zoom 0 if you want to do it that way. Hey, there we go. So negative 0.4x squared plus 240x minus 1100, 11,000. Window from 0 to 600. Zoom 0. So I'm going to do maximum, and I'm going to guess somewhere between 100 and 500, and my guess will be 253.2. Oh, I was so close. So at 300 tons, they will make $25,000 a month. Yes. All right, the domain of the profit function indicates that the company can produce any number of tons of fertilizer on the interval from 0 to 600 inclusive. Using the profit function, determine the value of the monthly production level X, which will result in the company realizing a negative profit. So all we need to do is find the zeros. So you can do second calc 0, and what do you get when you do that? So the roots are 50 and 550.